All right, but y'all should be able to see. This is just what QGIS looks like when you first open it. So here we'll just be opening a new project and getting some data loaded in. So we're going to start with some Chicago tract census tract data. And there are a few different ways to load in this data. My personal favorite is just super easy on this browser side here. It connects to all of your files on your computer if you allow it. So I'm just going to come down here and I'm just going to drag that shapefile in and get it loaded in. If your computer isn't communicating with this browser option for any reason, whether you don't want to allow it to or something's just a little buggy, you can also always come up to the layer tab at the top, add layer and add vector layer, and you'll get this dialog that pops up. I will say I occasionally run into a bug with this where when I select my data source, the dialog box will go away. But if you just reopen it, the data source you selected should be there and you'll be able to open it properly after you reopen the dialog box. So once you've got your vector layer up, something else we will want to do is add a base map so you can actually contextualize what you're looking at. So base maps are available through a number of different plugins. So you'll just want to go to the plugins tab at the top, manage and install plugins. And if you go to all, you'll be able to search for every plugin that's available on QGIS. We can go to installed to see what I have working currently. Quick Map Services and Quick OSM are really going to be a couple of the primary ones to find good base maps. And then just a little tip as well. If you go to settings, you'll see this show experimental plugins dialog. Sometimes you won't be able to see certain plugins that you're looking for without that. So if you're ever searching for a plugin and it's not coming up for some reason, make sure you have that box ticked. But yeah, like I said, Quick Map Services and Quick OSM are really what we're going to want to be looking at for just like some basic base maps. And once you've got those installed, you just go to Web, Quick Map Services, OSM, and then here I've just got OSM Standard because I don't have any other plugins loaded in this environment right now. So that's one way to add it. Another way to add base maps is if you have OSM Standard, it'll typically be here under these XYZ tiles. And again, you can just click and drag. And then we can reorder that so you can actually see the census tracts. And there you go. We'll be coming back to this project over the course of today. So I'm just going to go ahead and save this. And as we mentioned, it's important to have a good file system. So I'm just going to make sure this is going in the same file as all of my other data for today. And it'll just save as a QGIS file type. And when I go back up to here, I can now see it in my browser alongside all my other data that I'll be using today. As I mentioned, we'll be going through everything pretty fast today and just to get through kind of all the basics. But so it's very easy to check what your current coordinate reference system is in QGIS. All you have to do is right click, go to layer CRS, and you can see EPSG 4326 right here. And you'll notice that I have some of my most recently used coordinate reference systems listed right here. And it seems like it would be super easy just by selecting one of these to reproject my data. So what happens if I select this? It's my data has left the building. In fact, we can zoom to that layer to figure out where it went. And then just spend the next small eternity zooming out to figure out where it actually ended up. But if I remember correctly, I think this should end up somewhere around, what did I put this in? I put this in 3435. It'll end up somewhere in like mid to southern Illinois, I believe. Because 3435 is the is one of the best projections for Illinois, and especially for Chicago. So yeah. Oh, it's in Missouri. But yeah, it's a projection that's really suited for this area. So what I just did there was not actually change the data, change the projection. I just told the software to read it in a different projection. So it changed where the origin was and what it thought the units were. So we're just going to go back to 4326 here, and our data is back where it should be, actually in Chicago. So how you would actually go about reprojecting data, the easiest way is to go ahead, export, save feature as, and then you'll be able to change the CRS in here. So Chicago, as I said, EPSG 3435 is one of the best ones for that. It's an Illinois East projection. So we'll select that and then just get my data all in the right place here. And now it is in a new projection. And one thing that you can do to test if you're not sure if your coordinate reference system is projected or not, a really easy tool to use is to just go to the buffer tool, because this is a distance measurement. Here, if I'm in my projected data set, we see that distance is feet. It all looks fine. But if I switch to the GCS, GCS data set, it's in degrees, and I have a little warning right here because degrees are not a suitable distance measurement. So that's a really quick check if you're not sure if you're working in a projected system or not. And then you can also, sorry, my control panel ended up a little bit in the way. You can also come down here, and this is the coordinates system for the entire project. So this is how your project is going to display. So it defaults to 4326 typically. And if we change this to 3435 as well, it's also going to change how your data looks a bit. Just slightly reshape it. And using the base map is a little bit weird as well, just because OpenStreetMap is in Web Mercator, which is a very common, I believe it's 3857 is the actual EPSG, but it's yes, 3857, but it's like the standard coordinate reference system for web maps. So OpenStreetMaps, Google Maps, pretty much, I think Uber and Lyft use them as well. Almost any online map you see is going to be in Web Mercator, which is this projection, which does not line up with the projection we have here, but if we mess with it, stuff gets a little, it can get a little messy. So just changing the project down here will change the display. So you can have your display line up with your reference system of choice based on how what the projection you're using for your layers. So I know we just spent all that time harping on projected coordinate systems and making sure if you're doing measurements, especially, all of your projections are the same. But for the sake of ease today, so you don't have to sit here and watch me change the projections on like 5 more data sets, we are going to switch back over to our geographic coordinate system data set with the track data. So first here, we're gonna go ahead and add in a CSV layer. So very similar to how you would add in a vector layer, you can just go to add layer, and this will be a delimited text layer. And so the file we're going to be using for this is this affordable rental housing developments CSV. So we'll just get that loaded, and it has the same bug as the vector data. So I'm just going to reopen that dialog box and everything should be there. Yep. We're just going to check the X field, longitude, Y field, latitude. That looks good. Our GCS is 4326, which, as we went over, that's the most common one. If your data source does not list a coordinate reference system, it's probably 4326. So we'll go ahead and add that. And now we can see all of our affordable rental housing developments in Chicago overlaid with our census tracts. So unlike I don't believe you can just drag and drop from the browser as you would a GeoJSON or shapefile, just because you do have to do the extra steps of verifying that it's reading the data correctly in a way that you may not need to with GeoJSONs or shapefiles. It might still work if you choose to drag and drop from your browser, but I do prefer to go through the full steps using the add layer tool with CSVs just to make sure everything looks all right. And then, so we have this CSV layer that is now being mapped. To actually make that spatial data, we're going to go ahead and export that. Save feature as, we're going to keep the CRS the same instead of messing with it. And let's export it as a GeoJSON. And same as we've been doing, just making sure it's in the same folder I've been putting everything else, and go ahead and save it like that. And very notably, I'm not sure I'm not sure I touched on it as much as I meant to with projections, but GeoJSONs really should only be used with 4326. If you want to project to a different coordinate reference system, really recommend saving as a shapefile instead. You can also use geo packages, but we're not really going to be using them today. So GeoJSONs are great to use with 4326, but if you want to use a different coordinate reference system, use a shapefile. And then just for fun, I'm going to change this to something a bit more visible here. Just changing that in styles. And you know what? Green's a bad option because we have a red background. Making sure we're thinking about accessibility when designing our maps. So now we have blue on red. That's going to be a bit easier to see. Probably still not ideal, but it'll work for now. So that's converting a CSV to spatial data. But how do you convert addresses to spatial data? So that we're going to use the plugin MMQGIS. So I already have it installed, but just right here, MMQGIS is what you're going to be looking for. Anyone who's curious, the MM stands for Mike Min, who is actually a professor at UIUC. He's the one who created this plugin, and it's super useful. But once you have it installed, we're just going to go to MMQGIS, geocode, and geocode with web service. And here we'll be introducing another new data set, this time, if I can find it, there we go, the Chicago methadone node geometry. If you were to open this CSV in Excel, you'll see that we just have a list of addresses here. And then you'll be able to specify which field has the address, the city, the state, and if you include the country, the country. And just for the sake of keeping things consistent with our open source today, I'll switch that to OpenStreetMap. Change your file names as well. So just get these changed quickly here. And then we'll be able to go ahead and geocode this. And hopefully my computer doesn't crash, because it did almost crash this morning when I tested this to make sure everything was running smoothly. But it might take a few moments. And hopefully I'm still on Zoom by the time it finishes. All right, and there we go. And you can see at the bottom here, it says geocoded 27 out of 27, which is great. It means that there were no mistakes in the CSV file, so bad that it didn't even try to geocode it, which is a great sign. So we've applied that. Let's go ahead and close out of that dialog box. And then just a real quick way to inspect that everything geocoded properly is to hit zoom to layer. And we've zoomed in just a little bit closer to Chicago, which is a great sign. If we had zoomed out to start including different cities, we knew something went wrong. And you can also always open the attribute table and just kind of go through and make sure that everything looks right here, just line by line. That's not going to work for larger data sets, but if you want to take the time to do this in a smaller data set like this one, it's a perfectly fine way to inspect that. But that's why this zoom to layer tool is really important. It's just a very quick way of making sure that everything is showing up more or less where you expect it to. I have had typos that resulted in addresses being geocoded that were intended for New York, but ended up in England. So if you ever run into issues where something is ending up in the wrong place, or it's just not being able to geocode, there are a couple of big ways to troubleshoot. Just making sure that everything is spelled properly. You don't have any punctuation that is unexpected. The address that ended up in England instead of New York was because I had an apostrophe in a place where there was apparently not meant to be an apostrophe. So it's very little things like that, but that's why the more information you can give it, not just having address and city, but state and country, that can really help narrow down where these things are, where your points are meant to be, because a lot of addresses are so similar. Yeah. I know we promised y'all QGIS, Excel, and Geoda, and we've only been using QGIS so far, but we'll be using all three for this activity. So the first thing we're going to do is we're going to open this COVID cases, tests, and deaths by zip code CSV in Excel, and this is in the long format that we talked about. So what we can do to really get a look at that is custom sort by zip code, smallest to largest. And here we see we just have 30 rows of 60601 for each week that's available. So that's not going to work. So we're going to make a pivot table in order to make that from a long format to a wide format. So here we're going to make a pivot table specifically for the cumulative case data. So we're just going to hit that little button in order to select the data that we want to include. And because we just want cumulative, we're just going to pull the first 6 columns here. I'm going to go back up here. So my range is these 6 columns, and it's going to be added to this new sheet that I've made, which will be important for saving this as its own CSV later. So let's make our pivot table. We want our rows to be zip codes, so I'll drag that down here. We want our columns. We could use week number, week start, or week end, but for ease, I'll use week number. And we want that cumulative case data to be our values. So I'll add that as well. So we have our pivot table. We have some of these blank columns at the side here and at the bottom. So I'll go ahead and remove those. You can just use the column tabs here to remove unwanted rows. Notably, you won't be able to remove like these totals that you see here in the pivot table. But that is where saving it as its own CSV will be helpful. So I'm just going to save this as cases cumulative, and we'll see if that worked, because all right, that did work. So let's open up this new CSV, and at this point, we should be able to get rid of that top row or not. All right, well, this might be something to troubleshoot later. Yeah, sometimes it just doesn't like me as much. But we can go ahead and move on to the next bit. Google is always helpful for this sort of thing. So, oh, maybe it's because I did not open that properly. Okay, give me just a moment. Ah, interesting. Okay. Sorry, y'all. I don't think we have time to actually watch me troubleshoot this in real time. But just know that that's how you make a pivot table. When you can get it to save properly, it should work. So next we're going to be moving over to Geoda in order to actually merge this cumulative case data set with a Chicago zip code data set that includes a lot of SDOH data. So let's get that data set cleaned. You'll be using this zipmaster 1 that actually comes with this. For the sake of time, I've already cleaned up the data a little bit for today. If you've opened that zip code file, you'll see that there are over 500 zip codes listed. There are massive amounts of duplicates in that data set for some reason. And I have not found a better way to clean it than by simply manually selecting one row for each zip code. There are a couple of zip codes where you'll notice that there are actually differences between two of the rows. That's because those zip codes have exclaves. The exclaves are small enough that it's not going to be relevant to us today. Just choose the larger one, and you should end up with 58 zip codes. And if we open up the table, we can see the full data set. Let's just get that a little bit organized. So we have right now, we have zip codes, we have a lot of population data, race, age, and a couple other SDOH measures. So from here, we're going to go to merge, and we're going to merge that with our CSV. And if y'all don't mind, I'm going to use one that I prepared earlier just because I did not expect that little troubleshooting issue. So I'm just going to find where I put this together a little while ago. All right, that should be the right one. So this doesn't have longitude or latitude, so we don't really need to worry about that for now. And then we have the zip code data set. We have here, this is going to be our key to merge, and then include all of the cumulative data for every week. So we can just move everything over there, and then we don't need the zip code. So that can just be moved back, because otherwise we're just going to have a duplicate zip code, because it'll retain the zip, but it'll also move the zip code over, and we don't need that. So at that point, we can go ahead and hit merge, and we should see that there is a ton of new case data by week for each zip code. And if we're a little bit worried about anything that didn't code properly, we can just go to the last one. This won't work to check at the earlier ones because some zip codes didn't have any case data to begin with, but the lowest value for the final week in this data set is 14, which means that nothing is showing up as blank, which means everything geocoded properly. So now that we have that, we're going to go ahead and save this so that our zip code file is updated with this new COVID data. And we're going to move back to QGIS. And here we're going to be joining by attributes. Let's go ahead and take this track data off and get our new cleaned zip code data set added. And then let me just rearrange these things here. And that is a terrible color to be able to actually see anything, but it should be fine. Because I don't think we want that right now. Yeah, so we'll be joining the new zip code data with our affordable housing data. So in this processing toolbox right here, you can just search join. I've recently used it, so it's a little bit easier for me to find, but you'll be looking for joint attributes by location summary, because what we want here, we're going to be joining the number of affordable housing developments in each zip code to the zip code data. So here, we are going to go ahead and set it up. So this is going to be the feature layer that we're joining everything to. And here we're going to have our affordable housing development data set. We want to look at things that intersect, the fields that are going to be summarized. We just need the community area name since we're just doing a simple count. And count. And notably, let me just let it run so I can show you what'll happen. But there is a very high likelihood that we're going to get an error. And it looks like we have. So let's go back to parameters. So that error is due to there is a zip code that has actually an enclave that's not a part of Chicago that isn't translating properly between Geoda and QGIS. So if you just go to that, this little tool here, we can just say to ignore features with invalid geometries. And if we run it again, it should run properly. Yep, and we have our new joined layer. And then you'll notice it's a temporary layer. You will need to save these new layers. But if we go to properties, we can style it with our new count value, if I can find it. There we go. And just kidding, that didn't work properly. Every time you have to, even for like, I've worked on putting this together and I'm still, you do have to troubleshoot things. Sometimes if it doesn't work properly, you need to load the values to get the classes to appear. There we go. So now it should work. And you'll notice that there's nothing here for 0.